Hello class. I apologize for not being there today, but I'm going to go over the warm-up and also the notes via video. So please start off with the warm-up, pause this video until you have completed the warm-up, and then restart the video and I will go over the answer. Okay? Alright, so starting off, we're going to solve 2x squared plus 8x plus 6 is greater than or equal to 0. So the first thing I want to do is I want to factor. Now what I notice is first off, I have 2, 8, and 6. But all those are factors of 2. So what I can do is I can have my GCF out front, and then I can figure out what I'm left over with. So to get from 2 to 2x squared, I am going to multiply by x squared. To get from 2 to 8x, I'm going to multiply by 4x. And then to get from 2 to 6, I'm going to multiply by 3 is greater than or equal to 0. Now the nice part of this is now that 2 is multiplying, so I can divide both sides by 2 just to get what's in the parenthesis. X squared plus 4x plus 3 is greater than or equal to 0. This just makes your numbers a whole lot simpler for the problem, okay? So next what we're going to do is we're going to factor x squared plus 4x plus 3. That's going to be using our x method, okay? So you want to figure out two numbers that multiply to give me 3 but add to give me 4, and that would be a positive 3 and a positive 1. So you're going to get x plus 3 and then x plus 1 is greater than or equal to 0, okay? And now here's where I do my little side work, okay? So instead of worrying myself about the inequality, I'm just going to set each one of these parentheses equal to 0 to find my solution. So I'm going to do x plus 3 equals 0 and x plus 1 equals 0, okay? From there, what I'm going to do is I'm going to subtract 3 from both sides, and I would get x equals negative 3, and then here I would get x is equal to negative 1, okay? These are going to become your two benchmarks on your number line, okay? So when I'm drawing my number line, I'm going to start off by just drawing a number line, okay? And I'm going to put points on there that are around negative 3 and negative 1. So I'm going to do negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, okay? That's a number line that would look around where negative 3 and negative 1 are, okay? Okay, so I'm going to plot my two solutions on my number line, okay? But first off, I'm going to look at my inequality now, and I'm going to see it's an inequality with a line underneath, which means that I'm going to have a closed circle on negative 3 and a closed circle also on negative 1, okay? These are going to become your two benchmarks, and you're going to pick numbers between those intervals, okay? So looking to the left of negative 3, this is where I pick any number. I'm going to pick negative 4, and I'm going to figure out plugging in negative 4 into x plus 3 and x plus 1. So negative 4 plus 3 would give me a negative 1. I only want to concern myself with the sign. Negative 4 plus 1 would also give me a negative, okay? Keep going with the thought process. Between negative 3 and negative 1, I can choose negative 2. Don't choose negative 3 or negative 1 because you'll just get 0, okay? Hence why we set it equal to 0. So we're going to get negative 2. Negative 2 plus 3 is going to give you a positive 1. And then negative 2 plus 1 is going to give you a negative 1, okay? And then finally, greater than negative 1, I'm going to choose 0. 0 plus 3 is a positive 3, and then 0 plus 1 is a positive, okay? So now here's what I want to concern myself. I want to look at the products of these signs, okay? So a negative times a negative, that would be a positive, okay? A positive times a negative would be a negative, and then a positive times a positive is a positive, okay? Okay, so now last up, this is where I look at my inequality, and I notice that it's greater than or equal to 0. That means it has to be in the positive area, okay? So it's going to be in these two areas, okay? So how you would write your inequality, you would have x is less than or equal to negative 3, okay? And you have to include the other one, x is greater than or equal to negative 1, okay? And these would be your two answers to your inequality. So just make sure that you are checking that you got positive, negative, positive on that number line. It doesn't matter which numbers you chose, as long as you got that, you're fine, okay? So that's what we did yesterday, okay? So here's what we're going to talk about today. Jump to page in your book, 121, okay? And we're going to now be talking about imaginary numbers or imaginary units, okay? So let's start off with this, okay? To the side, I want you to draw like a box and then two circles, okay? So here's what you want to think about, okay? When we were talking about real numbers, okay, they are all the numbers in the entire world that we have concerned ourselves with thus far, okay? But unfortunately, those are not all the numbers in the entire universe, okay? All the numbers in the entire universe are what are known as complex numbers, okay? And that's going to be represented by the box. Okay? What complex numbers are composed of are real numbers and what we call imaginary numbers, okay? And these are the numbers that we are going to be talking about today. We're going to be talking about how to simplify them and also how to graph them, okay? So these are the numbers we're going to be talking about today. Okay, so what we're going to start off with is we're going to know the definition of complex numbers, I. We're going to know that complex numbers can be written as a plus bi, where a and b are real numbers. And then we want to graph complex numbers on the complex plane. So remember, complex numbers are composed of both real and imaginary numbers, okay? So we're going to be talking about what's the difference between both of those and how we can determine our imaginary numbers, okay? Okay, so I'm going to give a little history lesson, okay? Basically, when we were talking about, like, real numbers, we came upon the issue of when we're talking about x squared plus 1 equals 0, it has special mathematical significance. At the beginning of the 16th century, so a long time ago, excuse me, mathematicians believed that this equation had no solution. And this is why we also believed as a class and as like your past math classes that this would have no solution, okay? And the reason is if we were solving for x from this equation, okay, we would subtract 1 from both sides. We would get x squared is equal to negative 1, and then we would find the square root of that. And here's the issue. We can't find the square root of negative 1, so in the past, that's where we said there's no solution, okay? But today, we are going to change that, okay? So, like, basically how I like to imagine this is, like, when we were talking about, like, no solution, there was just no solution in our books. So here's what happened. Is this famous Italian mathematician, and I apologize if I say his name wrong, Girolamo Cardano. He published a book that was known as Ars Magna, and it's called The Great Art in English. In the process of solving one cubic third degree equation, he encountered and was required to make use of the same roots, the square roots of negative numbers. While skeptical of their existence, he demonstrated the situation with the famous problem. Find two numbers with the sum 10 and the product 40, okay? Okay, so we're going to do this problem in just a second, okay? But for right now, we're going to make sense of what he was talking about, okay? So to better understand this problem, we want to first find two numbers with the sum of 10 and the product of 21. So remember, sum is adds to 10 and the product is 21. Let's think about that for a second. Well, if I do 7 plus 3, that would give me 21. I'm sorry, that would not give me 21. That would give me 10. But then if we multiplied 7 times 3, that would give me 21, okay? So this is how kind of factoring came about. It was thinking about like what two numbers add and what same two numbers multiply to 21, okay? So now what we're going to do is we're going to take this example and we're going to let x represent one number, okay? I'm going to say, just for the sake of negatives, okay, I'm going to say x represents, in this case, 7, okay, from the above problem, okay? We want to write an expression for the other number in the term of x. So think about this. If the first number was 7, that second number was 3, how am I going to find 3 from 7? Well, I can just do 10 minus x. That's going to be our number 2, okay? So you don't actually need these numbers, but we just need the expressions, okay? So from there, we're going to use those two expressions to write an equation that models the problem in item 2. We want to find two numbers with the product of 21, okay? So starting off with that, I'm going to, the product means these two are going to multiply together. So I would have x times 10 minus x, and the product is 21, okay? Simplifying that, we're going to solve for x. We're going to multiply the x through. You get 10x, and then x times a negative x would be a negative x squared equals 21, okay? From there, we're going to solve. We want to set, remember, the equation equal to 0, okay? So I'm going to move things around, okay? I'm going to set my left-hand side equal to 0, and the reason that I'm doing this is because I always like my x squared term to be a positive, okay? Just for the sake of factoring. Okay. So I would get 0 on the left-hand side equals x squared minus 10x plus 21. And I would want to factor that. Factor two numbers, multiply to give me 21, but add to give me negative 10. That would be negative 7 and a negative 3. And you get x and x. Okay. So from there, using my zero product, I was able to do x is equal to 7 and x is equal to 3, hence why we got the two solutions from above, okay? Okay, so now we're going to expand upon this idea. What if we were to get numbers that were underneath a square root that were negative? What would we do from there, okay? So I'm going to skip over number 4, explain or solve your equation in two different ways. The first way, you can use quadratic formula, okay? But we don't need to know that for right now, okay? So I'm going to skip to number 5, okay? So now jumping back to the problem that Cardano posed, okay? He posed that we want to find two numbers with the sum of 10 and the product of 40, okay? So the sum of 10, remember, notice here, okay? 10 appeared here, okay? So what I can do is I can do 10 or x times 10 minus x equals 40, okay? And so you would get 10x minus x squared equals 40, okay? Okay, so we want to verify that the solutions to this problem are x is equal to 5 plus the square root of negative 15, and x is equal to 5 minus the square root of negative 15. We're going to use the quadratic formula, but I'm not going to go through the entire problem. I'm just going to show you how to set it up, okay? So first off, starting with the equation above, you want to get equal to 0. So I'm going to move everything from the left side over. So I get 0 equals x squared minus 10x and then plus 40, okay? So in the quadratic formula, a becomes 1, b becomes negative 10, and then c becomes positive 40, okay? Plugging it into this formula up here, okay, I would get negative b, which is a negative 10, plus or minus the square root of negative 10 squared minus 4, a is 1, and then 40 is c, all over 2 times 1. And what that would simplify is into two equations. Okay? You would get x is equal to, okay, 5 plus the square root of 15, and x is equal to 5 minus the square root of negative 15. Okay? We get those two equations. Now, here's where the problem comes in. Negative 15 underneath the square root. In our past, we would say that can't happen, so there's no solution. Okay, so we're going to now talk about how we find a solution using not only real numbers, but also imaginary numbers, okay? Okay, so in order for him to avoid any more problems, what he did is he wanted to create a solution to what is known as imaginary numbers, okay? So what I want you guys to underline are these two. X is equal to the square root of -1, and x is equal to the negative square root of -1, okay? What happens here, and I'm going to kind of like paraphrase a little bit, okay, is when we're talking about imaginary numbers, okay? Oh, that is not how you spell it. Imaginary numbers. We are talking about I, okay? That represents the imaginary number, okay? What Cariano proposed is that I is going to represent the square root of -1, okay? This is going to help you with how to solve these, okay? So either circle these, underline them, okay? This is key in understanding. You need to memorize that the square root of -1 represents I, okay? So expanding that idea, okay, if we have the square root of s, or negative s, okay, where s represents a positive number, it can be written as this. The square root of -1 times s, okay, in which the square root of -1 is I, so it would be I square root of s. That's how they got that, okay? So we need to know that the square root of -1 is I, okay? Okay, so what we can use is now we can use this idea of now including i's in our solutions, okay? So let's jump to the next page, okay? Okay, so the next page talks about writing the numbers negative square root of 17 and the square root of -9 in terms of I. So looking over here, okay, they start off with, I'm going to do a little sub-step, okay? The square root of -17 can be written as the square root of -1 times, now -1 to get to -17 would be a positive 17, okay? -1 represents I, and the square root of 17 stays the same, okay? And the reason the square root stays the same is because we can't divide like a perfect square into 17, okay? But now let's look at 9. Square root of -9, you're going to start off by writing as the square root of -1 times the square root of 9, okay? The square root of -1 is I, so that's the next line, times the square root of 9. But here's the thing, you can simplify even further. The square root of 9 goes into 3, okay? So instead of square root of 9, you would have I times 3, which is 3i. So make sure you're simplifying all the way, okay? Okay, so let's practice a couple of these. I'm going to do A and C, and then you guys are going to do B and D, okay? So start off by asking yourself, okay, if I multiply the square root of -1 times what to get to 25, -25, that would be just 25, okay? And now I can break it apart. The square root of -1 is I, and the square root of 25 is 5. So this would be 5i, okay? So please remember you can simplify whenever you have a perfect square, okay? Okay, so the next part is C, okay? You're going to start off the problem as you've done before. You're going to start off by doing the square root of -1 times, to get to -12, you would multiply the square root of 12, okay? Square root of -1 is I, times square root of 12. Now, do not leave it like this. I know 12 is not a perfect square root, but here's what you have to think about. You have to think about, can I divide 12 by any perfect square? And I can't. I can divide it by 4. So how I can write this is I can write I times the square root of 4 times 3, okay? And now looking here, the square root of 4 is just 2. So I can pull out the 2 in front of the I. So I'd have 2i, and I'm left over with the square root of 3. Okay, so in this case, what you're doing is you're simply saying, okay, looking at my perfect square roots, so like 1, 4, 9, 25, 16, so on and so forth, okay, can I divide that number underneath the square root by any of those? And in this case, I can, okay? Okay, pause this video, try B and D. B is done very similar to A, and D is done very similar to C. So pause this video and then start it up when you are done. Okay, so starting off, the square root of -7 can be written as the square root of -1 times the square root of 7. Square root of -1 is I, and then square root of 7 doesn't go into any perfect square. So it doesn't go into 4, definitely doesn't go into 9, so I can just leave it as the square root of 7, and that would be your answer, okay? -150. Square root, okay? Start off by doing the square root of -1 times the square root of 150, okay? Square root of -1 would be I times square root of 150. You can definitely simplify 150, okay? And the way to figure out that is, if you go to your calculator, think about like a number that's a perfect square that goes into 150. And in that case, 150 divided by 25 is 6, okay? So I can rewrite I times square root of 25, and you can write it like this too, times the square root of 6, okay? Square root of 25 is 5, so I can pull that number outside in front of the I, times the square root of 6, and that would be your final answer, okay? So just make sure you're refreshing on your perfect squares, so 1, 4, 9, 16, 25, so on and so forth, so that you're able to do this, okay? So here's what we're going to do next, okay? We're going to write the solutions to Cardano's problem using the imaginary units, okay? So let's start with that first one. 5 plus the square root of -15, okay? Start off by simplifying the square root of -15. I'm going to carry everything else down. Square root of -15 is square root of -1 times the square root of 15, okay? So I would have 5 plus square root of -1 is I. You need to memorize that. And then 15 doesn't go into any perfect squares. So it doesn't go into 4. It doesn't go into 9. It definitely doesn't go into 16. So you can just leave it as such, okay? Let's do the same thing, but with the other one. So 5 minus the square root of -15, okay? It's the same problem, just the minus has changed, okay? You would have 5 minus the square root of -1 times the square root of 15. Square root of -1 becomes I times the square root of 15. You leave that. And then you have -5, okay? Okay, so here's what the deal is. Looking at these two are written in the form A plus BI, okay? And this is what I mean. The number that is your starting number that does not have an I attached to it, that would be your A. So in both of these, A would be 5. Okay. The only thing that changes, and this is key, is when we're talking about B, we're not talking about the I. We're talking about what's in that square root. It's the number that's attached to the I. So in this case, B would be positive square root of 15. But in this case, because we have a negative here, it would be the negative square root of 15. And that is perfectly fine. We can have a negative outside of square root. We just can't have a negative inside the square root, okay? So when we are talking about this is going to help us out. This is in the complex numbers, okay? That's the form, complex form, okay? So what we want to have is when it says write in A plus BI, I want to see equations like these two. Oh, that should be a plus. I don't know why. Oh. Like that. So this is going to help us out with graphing now, okay? So jump to the next page, okay? First off, okay? The complex numbers have two parts, the real part A and the imaginary part BI. So for example, 2 plus 3i, the real is 2 and the imaginary part is 3. Also, to label your A and B, A would be that number sitting out front, that would be 2, and B would be 3. Okay. Okay, so really quick, we're gonna jump to number 12, okay? I'm gonna tell you what A and B are in this case, okay? So for number 5, or for A, okay, A would be that first part, okay? A would be 5, and then B would be 8, okay? For B, here's the deal. If you do not see an imaginary part, you have nothing. That means that you can add 0i, okay? 8 plus 0i is the same thing as 8. So in this case, A would be 8 and B would be 0. Okay. Similarly for C, if you don't see an adding, you can add 0 plus this, okay? So in this case, A would be 0, B would be the square root of square root of 10, okay? And then finally D, okay? You have to divide both by 2, so your A would be 5 over 2, and your B would be 3 over 2, okay? So just practicing labeling A's and B's, okay? Okay, so now here's where we're gonna jump. We're gonna jump to how can we graph this, okay? And off to the side, okay, this is what, I'm going to explain this in shorthand terms, okay, is draw your coordinate plane. So draw your y-axis, okay, and draw your x-axis, okay. In this problem, your x-axis represents, okay, your real number, okay. And your y would represent your imaginary. Okay. Okay. So let's look at 2 plus 3i. Here's how you would graph this, okay? That 2 tells you it's your real number, it's your a value. So you're going to go right 2 in your x direction. And that positive 3 is your imaginary number, so you would go up 3. So you graph that point right there, okay? You do not have to concern yourself with the I, you just have to worry about the numbers that are sitting next to the I, okay? So in this sentence, it says the point A and B represent A plus BI. So in this case, A would be 2 and B would be 3, 2, 3, okay? Okay, so let's look at example B. It says point A represents 0 plus 4i. That means that A is what's adding, so it's going to be 0, 4. So that's how they plot that point, okay? B, that would be negative 3, 2. So you go left 3 and up 2. That would be B, okay? C would be 1, negative 4. So 1 and then down 4. That would be C. And then D would represent 3, 0. Okay, there. Okay. So it's very similar to how you've graphed before. It's just now we're adding an I to the equation. Okay. Okay, so let's practice a couple of these, okay? It says graph 2 plus 3i and negative 3 minus 4i on the complex plane above. Okay, so looking at this, I like to write it as a point just to make it simpler for me, okay? 2 is your A value, so that's your first number, and then 3 is your B value. So it'd be the point 2, 3. So I go right 2 and up 3, and that would be this point. And I'm going to call that point E, okay? Try negative 3 minus 4i. I'll give you 2 minutes. Okay, if you need to pause this video for a second, that's fine. Okay, so in this case, it would be negative 3, negative 4. You want to carry those negatives, so you would go left 3 and down 4, and so it'd be that point right there. And I'm going to call that point F, okay? So that's basically how you're doing these, okay? Okay, I'm gonna show you E and F, and then you guys can try B, C, and D, okay? So starting off, I wanna draw my coordinate plane, okay? So, what's special about E and F? Well, here's the thing, is it doesn't have like all the terms. You want it in the form A plus BI, okay? But you can get it in that form. If we're looking at that first one, negative 2i, think about A is what's missing. If I have nothing in for A, it's really 0 minus 2i, okay? So that's going to be the point 0, comma, negative 2, okay? So graphing that, I'm going to go on my graph, I'm going to go left to right 0, and then I'm going to go down 2, and I'm going to call that point E, okay? Let's go the other way around. So negative 5. Negative 5, you don't have a I value, okay? So you want to write as negative 5 plus, if I have no I value, I have nothing. What number represents nothing? 0i. So this would be the point negative 5, comma 0. 1, 2, 3, 4, 5 left, and that would be F, okay? Okay, so that's how you would do graphing, okay? Try B, C, and D. Pause this video until you have completed it. Okay, so graphing B, it's the point 2, comma 5. So I would go right 2 and up 5, and that would be the point B. C is the point 4, comma negative 3. You want to make sure you're carrying that negative, so it would be left or right 4 and down 3. And then D would be the point negative 1, comma 3. So negative 1 and up 3. Okay. So make sure you have all those points on your graphs. Okay, so that's our whole introduction to the imaginary numbers and the complex plane. Tomorrow and kind of Tuesday, we're going to be discussing what it means to simplify, like I squareds and I cubes. But for right now, here's what I would recommend. I'm not going to give you guys this as homework, but I would recommend doing 18 and also 21, okay, just for practice, okay? But what the homework is it's practice check 7, and it's due on Tuesday. Remember, our quiz is on Tuesday, and I will go over tomorrow what our quiz topics are, okay? So make sure you're working on that. Whatever remaining time in class you have, you can work on practice check 7, but please make sure you're working. If you have any questions, just hold on to them till tomorrow, and I will go over any questions about this lesson, okay? Thanks, guys. Have a good one.